measure it in degrees, which is why we're doing it at the same time as angles. Most people don't know what bearings are, so we're going to get to that later on in the lesson. So first of all, our different types of angle. There are 6 types of angle to be aware of. So you don't necessarily have to know the full terms and ranges for these angles. However, sometimes it's just helpful to have a bit of background information. So at no point during your exam are you going to be asked to identify an acute angle, for example. As I say, it's good to hear the knowledge, get it in your brain. And there are a couple of these angles where we do need to know the value. So I'll explain that as we go. So our first type of angle then is an acute angle. And this is basically any angle which is measured between 0 and 90 degrees. Sometimes kind of refer to it as a sharp angle, acute being like another word for sharp. So if you said you had an acute pain, it'd be like a sharp stabbing pain. So an acute angle is like a sharp, arrowy type angle. Then we have our right angle, and this is a 90-degree angle exactly, always 90 degrees, there is no range. As you can see in our angles here, a lot of them have a little curve to indicate the angle. But in a right angle, we have this little square here. That is your clue that you have been given a right angle, because often in some of your questions, they will just draw the little square in the corner, and you have to look at that and know that that's what that is. So there'll be some examples of that coming up, so we can put that into practice. We then have our obtuse angles. So an obtuse angle is any angle that is larger than 90 degrees, so bigger than a right angle, but less than 180. So in that range there.
Morning.
Morning. We then have our straight angle. So this is another one where we have to remember that value of 180 degrees. So it seems a bit pointless because it's just a line. Why do we need that? But sometimes, again, when we're finding missing values, knowing how many degrees there are on a straight line will help us find missing values. Yeah, need to remember that that one is 180. We then have our reflex angles. This is another one with a range. So a reflex angle, it kind of looks like our obtuse angle, except instead of doing the smaller bit on the inside, we're going around the outside. And that's because it is between 180 and 360 degrees. It goes past a straight line, essentially. And then our final angle, again, doesn't really look like an angle, is called a complete angle or a full rotation. And that's 360 degrees. So again, we need to remember that it is 360. It's basically a full circle. So if I said to someone to turn 360 degrees, most of us know that means just turn on the spot and come back to where you started. That comes in handy when you are doing things like pie charts, knowing how many degrees there are in an angle. Although we're not doing pie charts today, obviously it will come in useful when we get to those sorts of graphs. So it's these three here where you have to definitely remember those values. Your right angle at 90 degrees, your straight angle at 180, and your complete angle or full rotation of 360. Okay, so the next thing we're going to look at then is angles in a triangle. So angles in a triangle, it will always add up to 180 degrees, just like our straight line, except we always need to remember this value. So you're often given questions about finding missing angles with triangles, and you need to use your knowledge of triangles to be able to solve that question. One of those facts you'll remember is it's 180 degrees. They're not going to tell you that information. There are 4 types of triangle that we need to be aware of. Only 2 of them tend to come up commonly, but there are 4 that we should be aware of. So we're going to run through these because there's different aspects of these triangles that are going to help us with different types of question. So our first one, an equilateral triangle. Does anyone know what an equilateral triangle is?
Does it all have equal sides?
It does, yeah. Yeah, so obviously it starts with that kind of equal word. I mean, it's spelt wrong, but it starts with equal. So again, we're going to pretend my drawings look equal. But basically what it means is that all the sides in a triangle are the same length, and that all the degrees in each angle are also the same size. Everything about it is super equal and regular and perfect, essentially. It's a perfect triangle. So,
can you say it again? Any angle with 4 sides, is that all right?
So all 3
all
sides
triangles
of
are 4-sided.
All 3 sides are the same length.
Does that make sense? Pardon?
All 3 sides are the same length. Lisa,
yeah.
Stop.
Yeah.
What are you trying to say?
All triangles have 3-sided shapes.
Yeah, because
all triangles
isn't it?
3 sides, yeah.
Equal. Yeah. Is that right?
Yeah.
Okay.
Okay.
Thank you.
So, if we have an equilateral triangle, all 3 angles are the same size. So, how much is each angle worth?
180.
No, 60.
$180 is our total of all 3 angles. So how much is each angle?
Are you working at the work? Okay.
Is
it 60?
Is 60?
It is 60. Good, yeah. In an equilateral triangle, each angle is going to be worth 60 degrees. Because they're all the same. Good.
Yeah.
And so, yeah, all we're doing is our 180 and dividing it by 3. So that's something that you need to remember as well, particularly because I have a question where that is going to come in handy later on in this PowerPoint. So there's a little hint for you. And that is for any equilateral. It doesn't matter how big or small the equilateral triangle is. Any equilateral triangle will have all angles of 60 degrees. Good, okay. So our next type of triangle is an isosceles. So I'm going to do this in a different colour. That's a horrible word to remember. It's a really horrible word to spell. But does anyone know what an isosceles triangle is?
Is it kind of where one of the sides is a lot smaller than the other side? Or am I getting that wrong? I've heard of it. I know all of these, but I just can't remember them from school.
Yeah, I think I know what you're talking about. So there's 2 ways you can have an isosceles triangle, and one of them I think is the one you're thinking of. So it can be tall and skinny, or normally, or they'll be sort of wide and short.
Yeah.
Yeah, so like that one in the bottom there is a lot smaller than the 2 tall ones. With an isosceles triangle, what we have are 2 sides the same length, so these 2 and these 2, and 2 angles which are the same size, so these 2 on the bottom. So any triangle that's an isosceles triangle will have 2 matching sides and 2 matching angles. They also have 1 line of symmetry, so a line of symmetry is basically a line where everything is reflected on either side. It's the same both sides. So if we've got 2 sides in this one on the left-hand side and 2 angles the same, our line of symmetry logically must be down the middle there, and the same on this one. So your line of symmetry, you could imagine if you folded your shape down that line, that both sides would match up evenly. It would make a nice fold. So, based on that premise, if our angle on the bottom here was worth 40 degrees, what would that mean for the angle at the top?
Would it be 100?
It would be 100, very quick, good. So,
You subtract 40 from 180.
Yeah, so we've got two angles on the bottom that are the same. If one side's 40, the other side is also 40. And obviously 40 plus 40 will be 80.
Yeah.
And we've got 180 degrees in an entire triangle, so we're just taking it away to find the missing angle. So our top one here would then be worth 100.
100, yeah.
That's always the kind of philosophy you're following. 180 degrees in total. What have I been given? What can I work out? Good. So our right-angled triangle, this one pretty much is as it says on the tin. It's a triangle that has a right angle in the bottom corner. I mean, it could be upside down, it could be in the top corner, it could be any way round. But the point is there is a right angle. Again, they'll give that to you. They'll give you a little square in the corner so you know it's a right angle. Based on that, if our bottom one here was 30, how many degrees is this angle X at the top going to be? 60, very good. So yeah, again, our bottom right angle triangle is 90 degrees. 90 and 30 will be 120. And we're taking that away from 180. So X must be 60 degrees. Good. One triangle left then. There aren't any rules for this triangle, really. It's kind of the odd one out. All the other, we have something nice. Everything's even, or it's two sides are even, or it's got a right angle. Our scalene triangle is basically all the triangles that I draw, where every side is a different length and every angle is a different angle. So A, B, and C, they would all be completely different numbers. There aren't any rules, as I say, to remember anything like that. And if you had to work out a missing angle in that triangle, they would have to give you two of the values because you can't magically work out the other one by thinking about symmetry or anything like that. So as I say, the ones that come up most often are usually the isosceles and the right angle triangle, because they can kind of give you two of those or one of those, and you have to work out the missing angle based on your knowledge of triangles. Okay,
They're the most common ones.
Sorry?
I said they're the most common one in exams, is it?
They're the most common ones, yeah.
Okay, thank you.
Okay, so I'm going to give you some practice questions based on triangles, like so. Give you a couple of minutes to solve these 4 questions, and then we can go. For example, this one here. We have a pentagon. So we could learn about pentagons, but as we've got here, it's basically a triangle on top of a square. So we've been told that this pentagon has one line of symmetry, and we need to work out the size of angle marked X. So first of all, where is our line of symmetry in this shape?
From the top to the bottom.
It is, yeah. It's basically going straight down the middle. Again, let's pretend I'm good at drawing. Straight down the middle, top to bottom of that shape. So if we folded it along that line, our edges would match up exactly. based on that, we can use the information we've been given to find our missing angle. So now I'm kind of throwing you in the deep end a little bit with this question, but does anyone have a possible way that we could solve it?
Is it 55?
Oh, it's not 55, but you're kind of not far off. How have you come to 55?
I've got two right angles that are 90 degrees each.
Mm-hmm.
And then I've added it to the 125.
Okay.
And then taken that away from 360. Is that wrong?
That is wrong, I'm afraid. Okay. Just because this is a 5-sided shape, so 360 is in a 4-sided shape. Okay. So there's a couple of solutions you can take. So one of them is if we know how many degrees there are in a quadrilateral, 360, and how many degrees are there in a triangle?
180.
180.
180, good. So if we add them together, we get the total number of degrees in that whole shape. So how many degrees are in the whole shape?
540.
540, good. Then what we can do is take away, like you were just saying, the angles that we know. So we've got our two right angles at the bottom are 90 degrees each. We've got 125 degrees here. What's the size of this angle on this side?
125.
Yep, it's also 125, good, because it's the mirror image. So if we add all of that up together, we can take that away from our 540. So what is our total of the angles we know?
430.
430, lovely. And then we do our 540 and take away 430.
$110.
110, good. So that's one solution. So I think, is it Carmelita? I think you're on the right track. But
Yeah.
Just taking it from 360. Obviously that was just for our square at the bottom. Good. So we can look at another solution. So what I'm going to do is get rid of some of my lines here. We're still going to think about our line of symmetry. Except this time what we're going to do is split it into a square and a triangle across that line that they've given us. What that's done is it's split our 125 degrees into two angles. What is the value going to be of the bottom part of that angle?
90.
It's 90, yeah, because it's in our square, so it must be a right angle. So that bottom bit is 90. So what is the amount of the bit in the triangle?
35.
35, good. Then we can just use our knowledge of triangles to do the same type of thing. So we know it's 180 degrees in a triangle. And we're going to subtract the angles we know. So we've got 35 on this side. So as we said a second ago, the other side is a mirror. That's also 35. So those two angles together are going to be 70. And if we take that away from our 180,